Okay, so in this review, I'm going through 4.3 to 4.4. The first three want me to simplify the expression if possible, so I want to go ahead and look to see if I can factor anything. My numerator in number 1 is going to stay the same, but on the denominator, both of those terms have an x, so I'm going to pull an x out. I'm left with 5x plus 2. Then if I take a look, I have an x on the top and bottom, so I'm going to cancel an x out. That leaves me with 3x on the top, and then 5x plus 2 on the bottom. And then because I got rid of the x on the bottom, I want to set that not equal to 0. And I don't have to solve, so it just stays that way. This is telling me I can't have 0 on the bottom because originally I had 0 on the bottom, and that would make it undefined. Same idea for number 2. Both of my terms on my numerator have an x cubed, so I'm going to pull that out. That leaves me with 6x minus 1. And then on my denominator, that's 2x to the 4th power. I have 3 x's on the top, so that'll leave me with 1 on the bottom. Then I have 6x minus 1 over 2x. Again, because I canceled out an x from the bottom, I want to do x can't equal 0. I also want to point out I can't cancel these out because of the subtraction sign in the numerator. This is one whole piece, and this is one whole piece on the bottom, so they have nothing in common, so that's going to stay the same. Over here, in number 3, I want to factor. I'm looking for what multiplies to negative 5 and adds to negative 4. That is negative 5 and positive 1. On my denominator here, I'm looking for what multiplies to 10 and adds up to negative 7. That is negative 5 and negative 2. So my negative x minus 5 will cancel out. I'm left with x minus 1 over x minus 2. And then for my denominator, I want to take the x minus 5, set that not equal to 0, and then solve. So if I add 5 to both sides, x doesn't equal 5. Same idea in 4 through 7, except I'm multiplying as well. So on these ones, I can either cancel out before I multiply across, or I can multiply across and cancel out. Typically, if I just have variables, I can do either way. If I have factored expressions, I'll want to cancel out first. So over here, I am actually just going to multiply straight across. So that's going to give me 54, x to the 7, because when I multiply, exponents add. And then I have y to the 4th. Then on the bottom, I have 9, x to the 5th, y to the 7th. You typically write your variables in alphabetical order. I can simplify. 54 divided by 9 is 6. And then my x's, this will leave me with an exponent of 2 if I cancel out 5 from the denominator. And then over here, this will leave me with an exponent of 3 on my y's. So I have 6x squared over y cubed on the bottom. And then I want to focus on the variables I canceled out for my domain restrictions. So x can't equal 0, and y can't equal 0. Over here on number 5, it's already factored for me, so I want to look at the factored pieces that I can cancel out from my numerator and denominator. I can take out an x minus 1, and I can take out 3 x's. So it's going to leave me with an x on the bottom. I have x plus 2 times x minus 3 over just x. Then I got rid of an x minus 1, so I want to set that not equal to 0 and solve. X can't equal 1. And then I also took out an x, so x can't equal 0. Number 6 is the same idea, except now I need to go ahead and factor my second fraction for myself. So I'm going to rewrite it. I'm looking for what multiplies to negative 7 and adds to 6. That is negative 1 and positive 7. So now I'm looking for what I can cancel out. I can cancel out an x plus 7, and I can cancel out an x squared. So that leaves me with x minus 5 times x minus 1 over 4. And then I got rid of x plus 7, so that can't equal 0. So x can't equal negative 7, and then x can't equal 0. Okay. On number 7, I want to factor. This is a difference of squares, so I'm going to have x plus 3 times x minus 3 over x. Then for my second fraction, I want to pull out an x. I have x minus 5 on my top, The bottom one is a difference of cubes. So this is following the pattern a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So my cube root of x is x. My cube root of 27 is 3. So I have x minus 3. Then it's going to be x squared plus 3x plus 9. I'm going to look for what I can cancel out. I can get rid of an x and an x minus 3. So I have an x plus 3 times x minus 5 on my numerator, and then just x squared plus 3x plus 9. Then I canceled out x minus 3. So x can't equal 3, and then x can't equal 0 because I also got rid of a 0. Numbers 8 and 9 want me to find the quotient. Here I want to flip the fraction and then multiply, so it's going to be similar to 4 through 7. So I am going to rewrite this. My first fraction stays the same. The second one I change into multiplication and flip it. Then I'm going to multiply straight across. So 28 times 2 is 56. Then I have x to the 9th y over y to the 16th. And I want to simplify. I can get rid of one of my y's, so it's going to change my exponent to 15. I have 56 x to the 9th over y to the 15th. Y can't equal 0. Over here I want to factor. Actually, I'm going to flip first. So I'm going to leave alone. And I'm going to change it to multiplication and then flip the second fraction. Then I want to go ahead and factor, so I'm looking for what multiplies to negative 6 and adds to negative 1 for my numerator. That is going to be negative 3, positive 2. On my denominator, I can take out a 3 and an x cubed. So that gives me x plus 2. Then I'm multiplying by 6x cubed over x minus 3. So I can go ahead and cancel out my x minus 3's, my x plus 2's, my x cubes, and then 3 and 6 is going to simplify that to 2. So that just leaves me with 2, and then I have to focus on things I canceled out from my denominator. X can't equal 0. I have x plus 2 that I want to set not equal to 0. So x can't equal negative 2. And then same thing for x minus 3. X can't equal 3 either. My answer is 2, and my x values can't be that. On 10 through 12, I want to find my sum or difference. These have the same denominator, so I just want to focus on combining my numerators. So 12 plus 3 is 15 over 5x. And then 15 and 5 is going to simplify to 3. So I just have 3 over x. I didn't get rid of any variables, so this is my final answer. Number 11, same idea. I am going to change this into plus and make that a negative 3. So I have x minus 3 over 9x squared. I can't factor anything out, so that just stays my answer. Number 12, I'm going to change that to a plus and that to a negative 3. So 7 minus 3x over x minus 2. Again, nothing cancels out, so I'm just going to leave that alone. This one wants me to find the sum or difference, but I need to make my denominators the same. So if I look, this one has 2x squared. It's missing the 3 from the denominator, so I'm going to multiply this fraction by 3 over 3. My second fraction has 1x. It's going to need a second one, and it's also going to need a 2. So I'm going to multiply my second fraction by 2x over 2x. On the top of my first one, I'm going to get 21 over 6x squared. Then I'm going to have negative 8x over 6x squared. I want to combine my tops now. So I have 21 minus 8x over 6x squared. 21 and 8 have nothing in common, so this is just going to stay my final answer. On number 14, this has an x plus 2, and this one has an x minus 1. So my first one needs to be multiplied by x plus 2 over x plus 2. And my second one needs to be multiplied by x minus 1 over x minus 1. Oops, parentheses. So on my first one, I want to distribute that 2. So I'm going to have 2x plus 4. And then my bottom I'm going to leave factored. On my second one, I'm going to have 4x minus 4 over my factored denominator. Then I want to combine my numerators, so 2x plus 4x is 6x. 4 minus 4 cancels out. I'm going to have x plus 2 over x minus 1. I didn't cancel out any variables, and I can't factor anymore, so this is my final answer. Same idea for number 15. This one I'm going to multiply by x minus 3 over x minus 3, and then the other side is going to get multiplied by x plus 4 times x plus 4, because that's what it's missing. I'm going to distribute. That's going to give me 6x minus 18 over x minus 3 over x plus 4. This negative up here, I'm going to change it to a positive and make that 5x negative so I don't forget. So that's going to give me negative 5x squared minus 20x over x minus 3 over x plus 4. So I want to go ahead and combine my numerators. It's going to give me negative 5x squared minus 14x minus 18 over x minus 3 x plus 4. I want to see if I can factor my numerator. I'm going to do this on a sticky note because I'm about to run off the screen. So, I am going to use the AC method. My A value is negative 5. My C is negative 18. A times C is going to be negative 5 times negative 18, which is 90. So I'm looking for two numbers that multiply to 90 and add up to negative 14. So I can use my calculator for this. Let me focus my screen really quick. So what I could do is in my y equals, I can type 90 divided by x, and if I go second table, I'm looking for two numbers that are going to add up to negative 14. So that's going to tell me, since my 90 is positive and I need a negative 14, I want two negative numbers. So I'm going to scroll, and I'm looking to add these. So negative 1 plus negative 90 doesn't give me the negative 14 I want. So I'm going to keep scrolling. Negative 5 plus negative 18 gives me negative 23. Negative 6 minus 15 gives me negative 21. That's not a whole number, not a whole number. Negative 9 and negative 10 gives me negative 19, negative 19. So it's not going to give me the negative 14 I want. That is as factored as I wanted. On 16, I want to go ahead and factor my first denominator. So I'm looking for what multiplies to negative 18 and adds to positive 7. That is negative 2 and positive 9. So my second fraction already has the x plus 9. It's just missing the x minus 2. So I'm going to multiply that by x minus 2 over x minus 2. My first fraction is going to stay the same. So 6 times x is 6x. 6 times negative 2 is negative 12. And then my bottom is going to stay the factored x minus 2, x plus 9. I want to combine like terms. So I have 6x, and then 14 minus 12 is positive 2 over x minus 2, x plus 9. I'm going to factor my numerator because they're both even. So I'm going to have 2 times 3x plus 1 over x minus 2, x plus 9. Nothing in common, so this stays my answer. Same idea for number 17. I want to go ahead and factor if I can. So I have x plus 2 over 2, and then I can pull out that 2 on the bottom, so it's going to turn into x minus 1. I am going to change that to a positive and change those signs. So my, oops, that was a positive. Why did I put that in? This is going to be plus 2x plus 1. Then I want to factor my denominator. I'm looking for what multiplies to positive 3 and adds to negative 4, which is negative 1, negative 3. So I'm looking for which each of my fractions are missing on the bottom. This one's missing an x minus 3. And then this one is just missing a 2. On this one, I want to FOIL out. I have x times x is going to give me x squared. X times 2 is 2x. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Denominator stays factored. Then over here, I have 2 times 2x is going to give me 4x. 2 times 1 is 2 over the factored denominator. Then I'm going to go ahead and combine like terms. So I have x squared. 2x minus 3x is negative x, plus 4x is 3x. Negative 6 plus 2 is negative 4 over 2 times x minus 1, x minus 3. I want to see if I can factor this. I'm looking for two things that multiply to negative 4 and add to positive 3. I can. That's going to be negative 1 and positive 4. So now that I have 2x minus 1s, those will cancel out. I have x plus 4 over 2 times x minus 3. I did get rid of something, so I want to set that not equal to 0. X can't equal 1. And my last part wants me to simplify the complex fractions. I can do this by either, on number 18, making them have the same denominator, or multiplying by the lowest common denominator. I'm going to use the LCD method here and the same denominator method on number 19. So, on this one, my LCD is going to be 4x. So I'm going to take this, and I'm going to multiply my top fraction by 4x, and my bottom fraction by 4x. Because I'm still multiplying by 4x over 4x, which is the same thing as multiplying by 1. So I'm going to go ahead and distribute this. I'm going to have 4x times 4 over x. And then I have minus 4x times x over 4. On the bottom of my fraction, I have 4x times 1/4 minus 4x times 1 over x. So, all of my 4x's are over secret ones. So I'm going to look at these each individually as a small piece. So right here I have 4x over 1 times 4 over x. The x's on the denominator will cancel out, which will leave me with 4 times 4, which gives me a 16. Then if I look at this piece right here, the 4's will cancel out, and then I have negative x squared. On the bottom of my fraction, I have 4x times 1/4. The 4's will cancel out, so I just have x. Over here on my last part, I have negative 4x times 1 over x, so my x's cancel out, which leaves me with negative 4. So, I want to rewrite my numerator. I'm going to rewrite it, so I'm going to pull out a negative, and my x becomes positive. Because typically we like working with positive variables. Then this is the difference of squares, so I can go ahead and factor that. That's going to be x minus 4 times x plus 4 over x minus 4. My x minus 4's will cancel out. So then I just have negative times x plus 4. X can't equal 4. And then also, because on my original fraction I had x's on the bottom, x can't equal 0. Okay. On number 19, I'm going to make them have the same denominator. So if I look just at my numerator, I want to multiply my first fraction by x minus 2 over x minus 2. And my second fraction by x minus 1 over x minus 1. So, on the bottom here, I'm going to multiply my first fraction by x minus 1 over x minus 1. And then my second fraction by x minus 2 over x minus 2. So I'm going to go ahead and actually solve that out. On my numerator, I have 3 times x, which is going to give me 3x, and then 3 times negative 2, which gives me negative 6. I'm going to change this negative into a positive and move that negative to my 5. So then I have negative 5. Oh, wait. I forgot to write my denominator. So then I have negative 5 times x is negative 5x. Negative 5 times 1 is positive 5. and then over my denominator. Then this fraction is still over another fraction. On the bottom, I have 1 times x minus 1 is going to be x minus 1 over x minus 1 times x minus 2. Same thing, I'm going to change this to a positive and make that 3 negative. So then I'm going to distribute. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6 over x minus 1 over x minus 2. I am going to combine my fractions now. On the top, 3x minus 5x is negative 2x. Negative 6 plus 5 is negative 1. Still over x minus 2, x minus 1. Then this fraction is over x minus 3x is negative 2x. Negative 1 plus 6 is 5 over x minus 2, x minus 1. I'm going to rewrite this as two fractions. So I have negative 2x minus 1 over x minus 2, x minus 1, divided by negative 2x plus 5 over x minus 2, x minus 1. The division can flip, or turn into multiplication, and then the second fraction will flip. So I have negative 2x minus 1 over x minus 2, x minus 1, times x minus 2 over x minus 1 over negative 2x plus 5. X minus 2's cancel out, x minus 1's cancel out. So I'm going to write my answer over here. I have negative 2x minus 1 over negative 2x plus 5. And then x can't equal 2 or positive 1.